Hi guys, so let's go ahead continue feeling a little bit more comfortable with our graphing calculator. After all, we paid good money for it, or we have someone that paid good money for it, or we got the free download from Texas Instruments for 6 months. Okay, so let's do this. So the directions, it's always nice to read the directions. So it says use your graphing calculator to find the following, round all values to one decimal place. So we are given a function which reads g of x equals x cubed plus 3x squared minus 15, and we are asked to find 1, 2, 3, 4 items. So 1, the x-intercepts, 2, y-intercepts, 3 local max, and then 4 local min. So let's do this. Yes, we are going to use our calculator, but it's always nice if we have a sense of what the graph should look like. So I'm going to go ahead, look at the degree. Oops, I'm not supposed to show that line. Okay, cool. So I'm going to go ahead and look at the degree, which is the code for biggest exponent on any of the variable terms. Since we have a degree 3 polynomial, then this is going to come off the cubic function, some kind of transformation. And the graph of the cubic function, you know, y equals x cubed looks something like this. Remember the famous what I call the Egyptian pose. So let's go ahead and graph it, and then we should have something like that. Okay, so we'll take our calculator, and we have x to the third power. So let me go ahead and show you the exponent key with my special effects. So the exponent key is that button that kind of looks like a hat, which is under the clear button. Okay, so it's kind of like saying raise 2. So depending on your model, one of two things: either one, the calculator on the left, the cursor is in the superscript area. For the calculator, I'm sorry, I don't know my difference between left and right. Yeah, I need to speak to my daughter. Okay, cool. All right, so the calculator on the right, the exponent is in the the cursor is in the superscript. For the calculator on the left, I don't have that. It actually projects the exponent key. Okay, so it doesn't really matter. So the caret key or the exponent key or the blinking cursor, either way, we want x raised to the third power. And then if you are in the superscript or exponent area, then we use our side arrows to get out. If you have the exponent key on your screen, then you just keep writing. Okay, so plus 3x squared. So remember, where is our x located? It's next to alpha. Cool. Another exponent, so raised to the second power, minus 15. So we already have a sense of what this bad boy should look like. So it's thanks to our quick sketch. Let's go ahead, enter graph. So graph is in the upper right hand corner. This time I said it right. Cool. All right, so let's go ahead, look at the Egyptian pose, and I'm having a issue. Okay, so all I see is a wannabe line. Okay, so we can just play with the windows at random, but I'm going to show you a really cool feature. We're going to adjust the window. We're going to adjust the window. We're going to go ahead, hit zoom, which is in the top row if you have a TI graphing calculator, and it's right in the middle. We hit zoom, and then we want to zoom out, so that way we don't have to play with the numbers manually. So we're going to hit scroll down to option 3, or zoom out. And the question is, where do we want to zoom out? I don't know where this graph is, so I'll just zoom out where the cursor is at the origin. So we're going to go ahead, hit enter. And yeah, we'll see a lot of tick marks, and I'll address that. Okay, so now let me go ahead, zoom in. Yeah, that was a bad idea. Okay. Cool. So I kind of see something that relates to my sketch. Cool. But notice how we have like a lot of blank space. I don't need that. So I want to go ahead, zoom in a little bit, but we're not gonna put zoom in, because if we do, we're gonna go back to the drawing board. Let me just put my cursor to the left. Okay, so I'm using my side arrows just to see how much to the left I should go. So that's about -4. I'm going to go to the standard viewing window. So I'm going to go from -10 to +10. So new to our life, we're going to go ahead, hit the window button, because I believe that together this is the first time that we've done it together. So where it says x min, that is code for what is the minimum for the x value. Right now it's at -40, but we don't need it to go that wide. So let's just go to -10. The standard viewing window for the for the X is from -10 to +10, and the standard viewing window for the Y is also from -10 to 10. So let's go from -10 to 10, and I really liked how it looked like vertically, so we're just gonna keep it as such. Okay, so again, we want to know what this looks like. Cool. All right, so that kind of matches our quick sketch, so I think we're good to go. But something what I want to point out, why is it that we have like nice tick marks across but like weird tick marks going up? So we're gonna go back to our window screen. So if we hit window, so the X minimum is -10, the X maximum is +10, and the scale on the x-axis is 1. So if the scale on the x-axis is 1, then we're counting by 1. So we have 10 tick marks, 10 tick marks, or 20 tick marks overall. For the y-axis, the minimum is -40 and the maximum is 40, and the scale is still 1. So we have like 40 tick marks going up, 40 tick marks going down. Yeah, that's 80 tick marks. Okay, so that's why it looks like this. But cool. All right, so let's go ahead, find the x-intercept, y-intercept, and the local extrema. Okay, so in this case, because we have to find the intercepts, I'm gonna go ahead and do a quick graph, but I'll include the axes. Okay, so cool, and then something like this, something like that. You know what, the axes are in my way, so we're gonna scratch that. I'm just gonna pretend like they're not there. Okay, something like that. Cool. So I want to find the x-intercept, the y-intercept, and then local extrema. So the local max, local min. I love maximum and minimum, so I'm gonna go ahead find those. So first, on my screenshot, we're gonna go ahead highlight those highs and lows. So we have a high point here, a high point there. Are we gonna find these highs and lows by hand? Of course not. That's why we have a nice calculator. Okay, so we're gonna tell the calculator, second calc maximum. Calculator, second calc minimum. So let's do this. So we have second calc, which is the behind key for trace, and then I like to answer these from left to right. So we have a high point here, so we're going to do second calc maximum. Cool. So let's go somewhere to the left. Okay, so my high point is I would say about there, so I think we're to the left. Enter. Somewhere to the right. Cool. And if you had to take let me move more. If you had to take a wild guess, where would be your maximum? I think we're pretty good. Cool. And that will give us -2, -11. Okay, so we have a maximum point, not a maximum value. So we have a maximum point at -2, -11. So what about this low, this value? Okay, this low point. So we want to find the local minimum. So again, calculator, second calc minimum. So we hit the second button, and we hit calc. And then remember, guys, you can pause and rewind this video as many times as you'd like. And then we want a minimum, so let's go ahead, select option 3 or minimum, and then we want to put our cursor somewhere to the left. So that low point is about here, so just put your cursor anywhere to the left of it. Okay, I think that's pretty good. Then we hit enter. I keep forgetting to say that, sorry guys. So again, our low point is here. Now it's saying right bound, so I need you to put your cursor anywhere to the right. So I think we're good right there. And then we hit enter. Guess. Let's go ahead and move our cursor where we think that low point is. I think we're there. And then depending on your model, you may either get a nice number, or you may get an undercover answer. Okay, so let's go ahead and talk about this. So the minimum says 1.46 E and then -6. This is a notation for scientific notation. So this means 1.46 times 10 to the -6 power. So in this case, when we move the decimal point 6 spaces to the left, that will give us 0.00000. Yeah, you got that right. 5 zeros. 0.0 whatever. 5 zeros followed by 146, which is code for 0. And if you're having a moment, then just look at the directions. Okay, round all values to one decimal place, and again, this 0.00000, yes, I need a manicure, is code for 146 is code for 0. Okay, so that will give us 0 comma negative 15. So I'm not quite sure why my calculator does that. I guess it just depends on the mood that's in. Okay, so I'm going to go ahead put this calculator to the side, and we're going to go straight to the local extrema. So I want to know, what is the local max? I know it says local maxima, but it's just easier for me to say local max. So we want the local max, so it's the local maximum value. So value, remember, y values only. If you need to speak to yourself, go ahead put the love notes, or we can put function values, but that takes forever to write, so usually I just put y values, or just y. We're gonna pretend you can read that. Okay, so the local max. So what are the local maximum values? So the maximum values are at the function values at those high points, which is only 1. Okay, so that will give us negative 11. Local minima, or you'll hear me say local min. So what is the local minimum value? So in this interval, or at this low point, the local minimum value, function value, is negative 15. So the moral of the story is that we have a local max of negative 11 and a local min of negative 15. Fantastic. So we're just 2 short questions to go. Okay, so x-intercept. So x-intercept, point where the graph intercepts the x-axis. Yeah, maybe I should have kept the axis, but I didn't. Okay, are we gonna do this by hand? If you want, okay, but we have a fancy calculator, whether a physical one or a virtual one, that again we can get from Texas Instrument or TI. So we're gonna do second calc x-intercept. Let's do this. So second calc x-intercept. And I'm having a moment because there is no option for x-intercept. I'm cool to find the minimum and maximum, but there's no option for x-intercept. And that's what we have to remember. What is x-intercept? So x-intercept is the point where the graph intercepts the x-axis. So at this point, whatever that is, the value of y is 0. Why? Because any point on the x-axis, value of y is 0. So if we think about functions, the x-intercept is the point where the graph intercepts the x-axis. What's so special about the function value? The value of the function is 0. So this is why you don't see an option for x-intercept. The different way to phrase it is 0. Okay, and we'll address that in about 2 more chapters, I believe. Okay, so for x-intercept, we're gonna do second calc 0, and go ahead, speak to yourself. You can put this keystroke, second calc 0, and then left bound. So the x-intercept is right here, so we want to put the cursor anywhere to the left of it. So I think we're good right there, but I'm just gonna put it closer for dramatic effect, and then we hit enter. Fantastic. Now right bound, I need you to put the cursor anywhere. Where do I put my pointer? Anywhere to the right of it. Okay, so let's go ahead. I'm still on the left side. We use our side arrows, and I think I'm to the right of it. We hit enter. Guess. Let's go ahead, move our cursor closer to where we believe the x-intercept is. And the x-intercept is not a rational number. Okay, so good thing that they tell us to round all values to 1 decimal place. So the graph intercepts the x-axis only at 1 place, so there's only 1 x-intercept to 1 decimal place. If my eyes don't fail me, that's about 1.77, so 1.8. Okay, so we have that the x-intercept to 1 decimal place is about 1.8. Fantastic. Just 1 more to go. Okay, so now we want to find the y-intercept. So y-intercept, point where the graph intercepts the y-axis. So again, I want to tell my calculator, second calc y-intercept. So let's go ahead and do that. Second calc y-intercept. But once again, we don't have the option that we wanted to look for. So in this case, we're gonna pretend we're gonna do it like by hand. Okay, so if we wanted to find by hand the y-intercept, what is that? Point where the graph intercepts the y-axis. And at this point, because I am on the y-axis, then the value of x is 0. Y just comes. It's just, that's how it is. Okay, any point on the y-axis, x is 0. So to find the y-intercept, we're going to let x equals 0 and then solve for y. Okay, so it's like, okay, I want to let x equals 0 and solve for y. How do we tell the calculator to say let x equals 0 and solve for y? So this is what we're going to do, value. Okay, so second calc value. So to find the y-intercept by hand, we're going to let x equals 0. So the calculator is asking me, okay, x equals what? Oh, to find the y-intercept, we're going to let x equals 0. Let's go ahead and put 0. And then we'll hit enter. And then that gives us, where am I? 0, negative 15. Okay, so sorry, I lost my place. Okay, so we have that the y-intercept is given by 0, negative 15. You can put the ordered pair solutions, or you can just put negative 15. I lied. Check with your grader or instructor. Same difference. Cool, so that's it. So again, we wanted to use our calculator to find the x-intercept, y-intercept, local max, local min. We addressed all four, so we're on it. Thanks, guys.